In our last video for section 2, we are going to just look at how we can figure out what a power function looks like if we don't have a graphing calculator with us. Excuse me. So what I have graphed here is a power function. It's got just any sort of number out front, the coefficient, and then the power again could be any sort of number other than 0, so we have to be a little careful with some of those things. And I'm going to change some of those values. So this is the power that I'm changing. What I want you to notice is that if we're just looking at the right side, I'm not going to worry about where x is negative quite yet. But if I just look at the right side, when p is greater than 1, it kind of has this idea of like a parabola sort of look. Okay, and as I change that value, okay, as it becomes maybe closer to 1, at 1 it's kind of like a line. When it's in between 0 and 1, it's looking more like a square root. And then when it's negative, it kind of looks like a hyperbola. And now we're just talking again about the right side of the graph. I'm not sure what's going to happen on the left side yet, but I can kind of see a few connections just based on the power there. And then the only thing that A does, kind of like we would expect, when A is negative, it just reflects over to onto the other side of the x-axis. But again, we have a parabola right now, then a line, then kind of this upside down square root, and now this hyperbola sort of thing. So we see some patterns there as we just look at the overall graph here. So let's try to summarize that in our notes. Get this going there. There we go. So to figure out the general shape of a power function, one of the first things we want to do is look at the value for p. So if you need to pause this and just copy down, but that's exactly what we talked about when we were looking at Sketchpad. Okay, then we want to figure out what the a value tells us. So if a is greater than 0, it's going to stay in the first quadrant. If a is less than 0, it's going to reflect over the x-axis into the fourth quadrant. Whatever shape we get here, it's going to reflect over. And then the last thing, which we really haven't talked about, is we need to figure out what's going to happen on the left side of our graph. So in general, these are always going to be either an even function, so that means there's going to be a reflection across the y-axis. It's going to be odd, which means we rotate it around the origin, or for some reason it's just not going to exist there. And so we can do this test for even, odd, or neither that we did a couple units ago, and that's going to tell us what happens in quadrants 2 and 3. So I'm just going to go through a couple of examples of that with you here. Okay, so if our first equation is 2 times x to the negative 3 power, if we go through those steps again, first thing I know is that a is 2. Okay, so I'm going to stay in the first quadrant, and p is negative 3. That means if it's negative, it's going to have this hyperbola shape. So we'll get to that here in just a little bit. But this is going to be the really tough part, deciding if it's even, odd, or neither. And our clue again, or the process here is we plug a negative x into the function. So I need to figure out how I can simplify this, how it's going to compare to the original statement that we had. And so that means maybe I have to rewrite some things because I can't quite simplify it yet. So first step I would probably do here is bring that whole chunk with the power, I bring it down to the denominator so that it has a positive power now. And now I'm at the point where I can think, what's negative x times negative x times negative x going to be? Going to be negative x cubed. I happen to take that out and pull it out to the front already. But we need to think, is that going to stay positive? Is it going to become negative? In this case, it becomes negative. Okay, at that point, we're kind of able to compare it. Maybe we bring that x cubed back up to the top. Now we can kind of compare to what we have right there. Okay, and we notice that it's the opposite of what we started with. So it's negative f of x. So when that happens, when I start with plugging a negative x in, and I can simplify, and I get a negative of the original, that means it's odd, that means it's going to have rotational symmetry. So now I put that all together, and this is going to be something like what my picture would look like. Again, a being positive tells me it's going to be in the first quadrant. P being negative tells me it's going to look like a hyperbola, and I don't really care how exact you are there, as long as it looks like a hyperbola. And then this part here taught me that it's going to be whatever I get right here, I rotate that 180 degrees, and that's what I would see on the left side. Okay, our next example is negative 0.4 times x to the 1.5 power. Again, we can think about what the right side is going to look like. Because A is negative, whatever shape I have is going to reflect into the fourth quadrant. Okay, reflect over the x-axis. And because P is greater than 1, I'm going to have a parabola kind of looking shape. And then I have to go through and do this test. So this one's a little bit more complicated, partly because of that 1.5 power. So I might want to think of that first as being to the 3/2 power. And then generally what I'll do here, we have to go through that process of reworking it and thinking of the denominator of 2 being a square root, and then the power 3 still being a power 3. I generally put the square root on the inside. Because I need to think of this as x being negative. I can't take the square root of a negative number. So whenever I get stuck like that, that's when we're going to say, okay, this is undefined, and we just have nothing in quadrants 2 or 3. It's just there's nothing that will exist there. And so we put all that together. It's a parabola sort of shape. I wish the curve was a little bit greater there, but it's a parabola sort of shape that has been reflected over the x-axis. Okay, so it's kind of a complicated process. Think about any questions that you might have and jot them down.